Hello, mathematics explorers. Welcome to Logarithms for Absolute Beginners. As this course is for beginners, it's going onto my YouTube called Variety and Fun Math. It's for people who've never studied logs before, or even if you want and you want a revision, that's fine. And to understand logarithms, one has to understand exponents. I'm giving a brief revision of exponents. And if you know this from before, no harm done if you see it again. Here's a question. What is 5 times 3? What does it mean and what does it equal? 5 times 3 means 5 plus 5 plus 5, 3 times, which equals 15. What's 5 to the power of 3 and what does it mean? It means 5 times 5 times 5, which equals 125. So of course 5 to the power of 3 is not the same as 5 times 3. And one more, what's 2 to the power of 4? It's 2 times 2 times 2 times 2, which equals 16. So there's a brief revision of exponents. Now I'm going to be nasty to you all because I'm going to ask a question which I haven't explained. So here I am being nasty. What is the log of 81 base 3 or the log 3 of 81? Or like if I say 2 to the 4 is 2 times 2 times 2 times 2 and it equals 16. The log of 81 base 3, what does it mean? And what would it therefore equal? See, that's my unfair question. It means what exponent do I raise 3 to in order to obtain 81? The question is asking, like this question is saying, what is 2 times 2 times 2 times 2? This question is asking, what do I power 3 by to reach 81? I know 3 times 3 times 3 times 3 equals 81. That means 3 to the 4 is 81. I power 3 to 4 to reach 81. Therefore, the log of 81, the base 3 equals 4, because 3 to the power of 4 is 81. And here comes a quick revision. 4 questions, 2 of them I've given away the answer, and the reason is we're going to talk about how we got that answer. What's the log of 32 base 2? The answer is 5, but why? Because 2 to the 5 is 32. The log of 27 base 3 is 3, but why? Because 3 to the power of 3, 3 times 3 times 3 equals 27. Now the answers are hidden. What's the log of 125 base 5? It's 3, because 5 to the 3 is 125. 5 times 5 times 5 is 125. And what's the log 36 base 6? It's 2, because 6 times 6 equals 36. 6 to the power of 2 is 36. Now I'm going to be nasty once more. I'm going to give you a question which I haven't taught. What's the log of 1,000? Something strange. I've just explained. We say, what do we power the base number to reach the given number? But I don't see any base number written in. The convention is if no base number is written in, we assume it's a 10. The log of 1,000 means log of 1,000 base 10. Therefore, the log of 1,000 equals 3, because 10 to the power of 3 equals 1,000. And if on your calculator there's usually a log button, that assumes base 10. In fact, I'll punch in right now 1,000 log, and I've got a 3, because the log of 1,000 is 3, 10 to the 3 is 1,000. Now, of course, I want to keep this simple, but people don't help noticing there's a key called ln. I mean, every calculator is different. This has capital LN. I've seen it with small ln. I've seen it with a capital L and a small n. And people often ask me what that ln means. It also means log. And the first log I just showed you means base 10. Ln means log with a base of a number. That number is called E, and it starts off 2.718. That E has many uses in mathematics. I'm not going to those uses now, but I'm just explaining that ln means a log with another number. Just like the first one is base 10, that's log with a base E. Okay? And just as a quick reminder, if I write log of 40, it's another way of saying log of 40 base 10. And if I say ln of 40, that means log of 40 base E. And you see I wrote the word teacher over there? That's a reminder for me because I wanted to tell you, I actually knew a math instructor the way he did it. And remember, I'm not telling you what to do. Usually you do what your own instructor tells you. I'm telling you out of interest. He never used a regular convention. If he wants to say log base 10, he would write that 10 in, like he would write log 10 of 40. If he wanted to say ln, he wouldn't write ln, he would write log, the number, and he'd write the E in. That's the same, like ln 40 and log 40 base E means the same thing. Now, his method takes more time and more work, but it's much easier to understand. If I see log 40 and little e, or log 40 and a little 10, and it's interesting. Okay, and now that raises the question, is why do we have logs? What's the uses? There are many, many, many uses in mathematics. Sometimes when we're dealing with big numbers, I know when they're measuring earthquakes with what's called the Richter scale, the amount of energy expands enormously and you get enormous numbers. So that take I believe it's the log of the amplitude of the waves, and you've got easy numbers to work with, like 3, 4, 5, 6, instead of these enormous numbers. And as long as you understand that these are logs. Another example is something expanding incredibly fast. Let's say it's chemistry and it's some compound, and as it's mixing with something else, its volume is increasing, or its mass is increasing very fast, 10 times bigger, 10 times bigger, 10 times bigger. It might be easier to work with logs. Instead of working with 10, 100, or 1,000, or a million, or a trillion, and enormously big, we take the log of the numbers. Like instead of saying 10, we say 1. The log of 10 is 1, because 10 to the 1 is 10. Or the log of 1,000 is 3, because 10 to 3 is 1,000. So instead of talking about these enormous numbers, we use another scale, which is the log of those numbers. As long as we understand it's a different relationship, like a 6 is not really double 3. If I said 6 pencils, that's twice as much as 3 pencils. But on this scale, this 6 represents timesing by 10 3 times. So this 6 does not mean double this 3. It's got to do with how many times we multiplied by 10. As long as we understand that, then we can use that with using logs. That's one of the uses. And then you might ask another question. It's all very well, you showed me on the calculator, that log is base 10. And that's ln, which we don't have to understand now anyway. What if I'm doing log with another base? What if I have this question? The log of 50 base 3. The one on the calculator is base 10. I'm about to teach you something called the change of base formula. I'm not going to prove why it's true. It'll be a great idea to do it on another YouTube. This formula says, if I have the log of some given number, let's call it x, to base a, it equals the log of x over the log of a to any base number as long as top and bottom is consistent. For example, the log of 50 to the base 3 equals the log of 50 over the log of 3. to any consistent base, the top and the bottom. I always say with mathematics, everything I do, there's always two concepts I look for. It has to be mathematically valid, i.e. true, and it must be helpful. I'm giving an example of true but not helpful. What I wrote is absolutely true. It equals the log of 50 base 7 divided by the log of 3 base 7, as long as those base numbers are the same. Absolutely true, but it's not helpful. It's making it more difficult. But I can choose a base which I can work with. I can say it equals log 50 over log 3 to a consistent base, the top and bottom. I use that base 10. That's both true and helpful, because on my calculator, I can plug in log 50 equals divided by the log of 3. That will give me the answer, as my calculator is in the base of 10. And the one thing I love about logs is that it has many uses. And here's one very interesting application to logs in this beautiful picture. While I display this application of logs, I'll just mention that logs are used many times in math, and I always think of mathematics is like a tool. You know, a tool solves a problem. Let's say a hammer. There are times where a hammer is useful, other times it's not. The more you use the hammer, the more you learn where it's better to use a hammer. Other times you're better using another tool. Same with logs. When you get into more advanced maths, there are some equations you use logs to simplify it. They actually make it easier. And there are other equations, putting in logs will make it harder. And the more you work with logs, the more you will learn where it's helpful and where it's not helpful. And the more you learn math, you will realize so many uses of logs. I hope this lesson has given you all a great foundation. Please, in the comments, put down anything you would like me to teach you, or any concept you want to even learn for the first time. If it's for more advanced, it will go to my other YouTube called Martin Tutorials. And if you enjoy these lectures, please click subscribe. Thank you all, and I'll talk to you all soon.